So, blood pressure and hypertension. Blood pressure we'll discuss as a normal factor that changes as we exercise and we do various things throughout our day. But hypertension, a cautionary note, is something that we need to avoid in order to have balanced, active, healthy lifestyles. Obviously, both relating to the cardiovascular system. So, specification asks us to be able to define blood pressure and to know what resting values and units of blood pressure might be. And also we need to be able to explain the changes that occur when we exercise. So how does blood pressure respond to exercise, different kinds of exercise, and also explain what we mean by hypertension. So what is blood pressure? It's something that is actually necessary, that we need. We need an element of pressure to help us circulate the blood throughout our body, up and down in our body. And basically it can be defined as the force that's applied by the blood against the blood vessel walls. So it's a force that is variable, so we have a greater or lesser forces, but interestingly blood pressure can be very high, excessively high and unhealthily high, or can be unhealthily low. It's measured in millimeters of mercury, so mmHg. Now we actually have two values when we give a blood pressure reading. One is our systolic value, one is our diastolic value, and you should know that systole means contraction. So this systolic value is the higher value, and it's the pressure that the blood exerts on the blood vessel walls during the contraction phase of the heart, obviously when blood is being ejected at force. And the diastolic value is the lower value, and that relates to the pressure exerted by the blood on the walls but during the relaxation phase of the heart. 120 over 80 millimeters of mercury is about average. You may have all had your blood pressure taken. You may not have had it done like this with a little pump, a scale, and the stethoscope. You may have had it done automatically, which is much more common nowadays, putting a cuff on your left arm round about your elbow. The cuff inflates, and as it deflates, it takes two readings, and here you can see somebody's reading 121 over 55. That diastolic value is a little bit low, but not desperately so. 120 is about average, so 120 over 80 is what could be accepted as very much a normal blood pressure. So what sorts of things affect blood pressure, because these values do change? It's affected by the resistance that the blood vessels have to the blood flowing through. For example, if there's vasoconstriction or tension in the blood vessels, they're narrower than they should be. The blood will struggle to get through and will put extra force on the blood vessel walls because it's struggling to get through. The blood viscosity, which pretty much means how thick the blood is or how watery the blood is. So if you're dehydrated, you might have more viscous blood. Cardiac output is directly related to blood pressure, so the more blood you have circulating around your body during exercise, the more pressure the blood will exert on the walls, and also blood volume. If you have less or more blood volume, that will change your blood pressure values. So as I mentioned, these factors can affect vessel resistance, vasoconstriction, or some of the diseases we learn about, which might narrow the lumen, or dehydration might affect blood viscosity. Heart rate and stroke volume, obviously, if they go up, so does cardiac output, and that means that so will blood pressure. Pause the video and just have a little look at this. This just talks through essentially what I mentioned just a moment ago, but it gives you kind of a flow diagram of how blood pressure might be affected by these, blood volume, the cardiac output, resistance, and so on. Here again is our resting values of blood pressure, so make sure that you learn these. Systolic would be 120, diastolic would be 80, and you write it with a line between them like a fraction, so 120 over 80. Make sure you put the millimeters of mercury in there also. And I've explained already that the higher value is regarding systole and the lower value is diastole. Now, again, this really just very quickly shows you how blood pressure values might change depending on the blood vessel we're looking at. Once blood is ejected from the heart, the left ventricle, it is at high pressure, high velocity, high speed and high force. Obviously it's just been ejected from the pump, so we get this huge variation, 120 large, big changes between the pressure and the diastole and the systolic values. As the blood moves through the arteries, gradually going through smaller arteries, these changes might drop slightly. Diastolic pressure gets a bit higher. And as it goes through the arteries, the values might decrease slightly. As we go through smaller and smaller branches, eventually heading towards these minute, tiny capillaries. Whilst they're individually tiny, there are thousands of them. So the flow of the blood is greatly reduced, and also the pressure reduces. So much so, blood pressure drops to the point where entering the right atrium again, it's practically zero. So venous blood has very, very low blood pressure, and that's why we need things like our muscle pump and our respiratory pump and valves to help us return this blood at very low pressure and slow speed back to the heart. Have a little look at this. Ideal blood pressure has a range, and obviously ideally at rest you're between those. Low pressure can be a problem in terms of circulation and getting oxygen to our brain. This is yellow is the kind of warning levels. If you are consistently between 120 and 140 systolic, that's a concern. And absolutely it's a concern if you're above that value consistently, not just when you exercise, but all the time. Again, pause the video and just have a little look at this about the control of blood pressure. So blood pressure will go up because the baroreceptors in your carotid arteries have told your or via sensory neurons have told your cardiovascular control center or your vasomotor control center that pressure is up. This will mean that the sympathetic nervous system will relax or stop its stimulation, reduce its stimulation of the arterioles, which means that they will relax and vasodilate, which if they widen and vasodilate, the resistance of those vessels will be less, and therefore blood pressure might drop. Similarly, there'll be greater parasympathetic stimulation, which will basically mean that the SA node will stop firing as rapidly. The force of contraction and the heart rate will drop, which means that cardiac output drops, and therefore hopefully blood pressure will too. So reduction in sympathetic stimulation means vasodilation, means resistance drops, means blood pressure drops, and also an increase in parasympathetic stimulation means heart rate drops, cardiac output drops, and again blood pressure drops. So what happens to blood pressure when we exercise? Now we need to know what happens during aerobic or endurance submaximal exercise, what happens during maximal exercise, and also what happens during isometric contractions where you sustain constant static contractions with your muscles. And this diagram pretty much shows. So from rest, as we begin to exercise submaximally, blood pressure values will go up, the systolic value goes up. Linearly, as we exercise harder and we put more strain on our muscles to the point where we're very stressed up there, and you can see it can go actually quite high, up to nearly 300 millimeters of mercury. Our diastolic value doesn't go up straight away, but does eventually, and goes up to a point here. So it can go up to maybe 170-ish. So maybe you could have a value of, if you're working incredibly strenuously, 270 over 180. So dynamic exercise, where we are repeatedly rhythmically contracting our muscles and moving, systolic goes up linearly, diastolic doesn't particularly change. There may be a little bit of change, it might increase a bit, but doesn't dramatically change. So there we have a dramatic or a linear increase with systolic and no increase with diastolic. Now if we look at static or isometric exercise, where you're constantly strained, constant static contraction, we have a different picture. You can see that our systolic goes up again linearly, but perhaps a little bit higher, but also our diastolic pressure goes up, and that's a lot to do with the fact that there's no circulation of blood because our muscles are constantly constricted or constantly contracted. So blood pressure generally fluctuates. We need to understand that. Throughout our day there could be all sorts of things that will affect our blood pressure. Systolic linearly increases with aerobic exercise. Diastolic doesn't change particularly. If diastolic goes up more than 15 millimeters of mercury, then that's a problem. Systolic will pretty much plateau at the upper levels during submaximal exercise, so 140 and 160 millimeters of mercury, although it might drop a little bit during very, very prolonged activity due to something called cardiovascular drift. Maximal exercise, however, systolic blood pressure increases linearly, and also diastolic does. So it can go particularly high, possibly even higher with extreme, as we saw in the graph before. Some elite athletes have recorded 240 to 250 millimeters of mercury, so very, very high. That should be 240, not 24. Blood pressure and isometric exercise. If we have sustained static contractions, this will restrict our blood going through. It's basically like you putting your foot on a hose pipe. The contraction blocks the flow of blood and pressure builds up behind that. As a result of that, both systolic and diastolic values will increase, exceptionally high. This could be also added to by this Valsalva maneuver, where you kind of hold your breath in when you're straining like that, and air doesn't release from your body. So isometric exercise actually can be very counterproductive if you have high blood pressure. You certainly shouldn't do it for very sustained levels. Just be mindful that blood pressure might change depending on your body position. If you're seated, it will be moderate. If you're prone or lying down, it should be quite low because your cardiac output will be quite low. You're not having to work as hard against gravity like you do when you're standing up. And actually, if you're inverted, for example, in a handstand, blood, easily returns to your heart, so it's almost an advantage, really. So I would expect here blood pressure for standing to be higher, seated to be middle, prone to be least. Have a little look at this. Mark this question. Explain the change in heart rate that occurs during the performance of a headstand. Why is it advisable to use distributed practice when trying to improve a headstand? Pause the video and just have a look at the mark scheme in more depth. In recovery, ideally blood pressure should return to normal, but sometimes the systolic values can stay higher, a little bit elevated after exercise, as long as it does go back down. Diastolic can even remain lower for longer. But if these remain, and this in particular remains high, excessively high, for a period of time afterwards, then you need to seek medical guidance. So we'll leave this video there, and I'll continue about blood pressure in part 2.